Now that we're hopefully happy to identify the right coronary artery in different views from cartoons, we're going to look at some real angiographic images to see if we can still do this. It's always a little bit difficult to outline things for you on a moving image, and so we'll run through things fairly quickly and then select a frozen frame to highlight the important points. We're starting again in the LAO 40-degree view, which hopefully you'll recognise. The whole of the right coronary artery is seen in profile. The origin of the right coronary artery is well seen, with contrast refluxing back into the aortic root following injection. There's a small branch coming off superiorly, right at the start of the right coronary artery, which is the conus branch. You'll also see another small artery coming off, which is probably the artery to the SA or sinoatrial node. The mid-right coronary artery then gives rise to a small RV marginal branch before it continues to give a further small acute marginal branch. It then becomes the distal right coronary artery. The right coronary artery distally then bifurcates into the posterior descending artery, or PDA, and the posterior left ventricular branch, which also has subsequent branches of its own. Here you can see the frozen frame. Here's the ostium of the right coronary artery. Here's the angiographic catheter. The branch superiorly here is the conus branch, and this small branch, most probably the branch to the sinoatrial node. Here's a small right ventricular marginal branch, and another small acute marginal branch. Here's the distal right coronary artery, and here's where it bifurcates. The most superior vessel is probably the posterior left ventricular branch, and this vessel is the posterior descending artery. Moving to the LAO 40 cranial 25 view, you can now appreciate that the distal bifurcation of the right coronary artery is much more obvious in this view and much more easily definable as to which branch of the distal right coronary artery is the posterior descending artery and which branch is the PDA. This view is particularly helpful in assessing for disease involving the distal right coronary artery bifurcation or the ostium or origins of the posterior descending artery or posterior left ventricular branches. Here on the frozen frame we can go through things again. I want in this view you mainly to concentrate on the distal right coronary artery, which is being highlighted here. Can you see how much the bifurcation has been opened up in this view? The superior branch again is the posterior left ventricular branch, and these are branches from this posterior left ventricular branch. This branch here is the posterior descending artery, which is easily seen. In the REO view, you can now see the mid-right coronary artery in its full profile much more easily. You will notice, however, though, in this view, the ostium and the proximal right coronary artery are what we call foreshortened in this view due to the position of the image intensifier, and so they're not as easily seen as in the previous views. The full length of the right ventricular and acute marginal branches are easily seen in this view, as is the full length of the posterior descending artery and its branches. You can now hopefully start to see all the small branches passing up from the PDA to supply the inferior wall and ventricular septum. Let's again look at this frozen frame. Here you can see the foreshortened proximal right coronary artery we were referring to. Here's the RV marginal branch in profile, as is the acute marginal branch shown here. This is the posterior descending artery here, and you can see all the small vessels supplying the inferior wall of the ventricle coming off the posterior descending artery.